Julian, chapter is going a bit slowly, no problem. So we are not in very hard and fast. Uh, Application of in total internal reflection of life we are discussing, and today endoscopy, colonoscopy was also discussed, right? Endoscopy, actually, endoscopy and colonoscopy they use optic fibers. Some small wires are there which contain glasses, small glasses, and total internal reflection takes place. And for that, either that small wire or pipe is passed from our mouth or from anus also. If it is passed from mouth, then we can see the activities of up to stomach, esophagus, right? If from anus, then up to colon. So colonoscopy and endoscopy, right? Oh, they'll just find out all these things. Okay, it was discussed yesterday. Now today, who is going to explain? Simresh. Okay, Simresh presentation here. So let's welcome Simresh for his presentation. I think this chapter may be completed today, right? This portion. Then again there will be length. Yes. Now everybody.
So, namaskar everyone. So, I'm going to explain about the chapter of wave. Use of optic fibers in communication. So, optic fibers are ideal for high-speed communication because they use light to transmit information which can travel at an incredibly fast speed. To understand this, let's compare optical fibers to traditional copper wires. So, copper wires transmit information using electric signals and which move relatively slowly. Application of optical fiber is used by telecommunication companies to transmit telephone signals, internet communication, and cable television signals. It is also used in other industries, including medical, defense, government, industrial, and commercial. The source of light in a transmitter can be either a semiconductor laser of a light emitting diode LED. With either device, the light emits in an infrared. So the lasers and LEDs used in this application are tiny units, less than half the size of the thumbnail, in order to match the size of the fiber to transmit information by light waves. Reflection and total internal reflection of sound. Reflection index is defined as the ratio of the sine of the angle of incident SI to the sine of the angle of reflection S sin R. Total internal reflection occurs when a ray of light reflects inside a medium instead of refracting, resulting in no fraction and following the law of reflection. Hearing is difficult from afar because sound waves curve upward. The figure shows how nighttime shows were reflected at various events between them. Here is a figure of the reflection and total internal reflection of sound. There is prism and dispersion of light. So prism is a piece of glass or transparent material. The precise angle and the plane efforts are used to analyze and reflect the light. A triangular prism is used to separate the white light to its constrained colors, which is known as spectrum. Lights with different wavelengths reflects in different amounts. The dispersion of light is the phenomenon of splitting of a beam of light into its 7 constituent colors when passed through a transparent medium such as prism. So this is one video, it's not open. Yeah, not opening, I guess. No. So what is it? Causes of dispersion of light. White light consists of 7 different colors of spectrums, and different colors have different wavelength. So here is the cause of light: red, range of wave, and color of light and range of wavelength of different red, orange, yellow, and green. Thank you. The video is not coming.
Yeah. Actually, this is the system. See, it shows your identity. Thank you for your email, simresm@gmail.com. That is made by. This is his pattern. If somebody wants to use, the person must get permission from you. This is the way. Very lovely, right? Okay, thank you very much. I is there, okay. Without mic also my sound comes. Bang, sound comes here. Why do you damage it? Okay. We are discussing the portion light, and here use of optic fibers in communication. You can see here those fibers. Um, this yellow colored one, this is made up of glass. It is made up of glass, right? And again, it is that is the central part. It is called core, and it is covered by one another material. We call it cladding, right? And there is next plastic coating. Three layers are there, and signals they transmit from this one with the help of glass, and there is total internal reflection. And who uses such type of fibers? Internet suppliers, cable companies. Next one, this telephone suppliers. Next one in industry, medical, defense, government, etc. Right? Next one is here. So, what is here? Next thing you have to remember LED. Now it is become quite famous, right? So there is one LED bulb. Can you see?
Yes.
Earlier the bulbs used to damage very quick. If fallen down, broken. But nowadays you can change. Again you can make it. So these are LED. Full form of LED is light emitting diode. Okay. So um, they are much better than others because they provide more light in comparison to others, right? Now here is next thing to discuss. Light is, I mean, sound is heard louder at night in comparison to day. Yes or no? Why do we hear sound louder during when? Day or night? During night. You can see one diagram. This is the condition of day. This is the condition of night. What happens during day? Down there is warm air, up there is cold air. Warm air means density is high or density is low. Warm air, density is low. Cold air, density is high. So when somebody produces sound, then it travels from the layer with less density to more density. What happens when wave travels from less density to high density? It bends towards the normal. It goes upper one, right? And doesn't return back. That's why it doesn't cover wide area. But during night time, lower surface is cold, upper surface is warm. When sound is produced, it goes from cold layer to warm layer, cold layer to warm layer. Then again, there is total internal reflection. Okay, total internal reflection, and it covers wide area, wide range, and the sound can be heard clearly. So sometimes what can we say? Why is sound heard clearly during night than day? It's because of total internal refraction of sound. What's the reason? Total internal refraction of sound. Another thing he has given this one. So here is our prism. This is when one triangle is made and this white light is supplied. Then it splits into how many colors? The process of splitting into 7 different colors is called dispersion of light. While going from one medium to another, it bends means that is refraction of light. The process of returning back in the same medium is called reflection of sign, reflection of light or sound. But if a ray of light divides into how many colors? 7 different colors. That phenomenon is called dispersion of light. And here is band of 7 different colors. Band of 7 different colors. This one. So this is the screen. What is this? Screen or spectrum. We call it spectrum. What is the spelling? spectrum. So the spectrum contains colors in order. Colors in order. What is at the top? Red. Next one, orange. Next, yellow, green, blue, indigo, violet. So, VIBGYOR. What do you call it? VIBGYOR. Vibgyor. And who was the first person to give this technique? Sir Isaac Newton. Newton has demonstrated by combination of 7 colors, white light was produced. So white color is mixture of 7 different colors in proper amount. Okay. And why does light disperse into 7 different colors? It's given here. Cause of dispersion of light. How many colors are there? 7. What are they? Red, orange, yellow, green, blue, indigo, violet. Look at the speed of each color. Which color has the highest speed? Red. 6.2 times 10 to the power minus 7 meter to 7.8 to 10 to the power minus 7 meter. That has highest speed, right? Which has least speed? This is not the speed, this is wavelength. What is this? What is wavelength? Remember, suppose if it is traveling in this way, at that time, the distance between these 2 points, this is called crest. What do you call it? Crest. Upper point is called crest. This point is called crest. These are all crest. Lower point is called trough. TROUGH. What is this? What is this? Crest and trough. Distance between these 2 points is called wavelength. Distance between these 2 points is called wavelength, is denoted by lambda, Greek letter lambda. And obviously, more wavelength, more speed, less wavelength, less speed. So, when light is traveling in air, all the colors they travel with same speed. But when the medium changes, when it goes in glass or water, at the time speed of light decreases or not? If the speed decreases, then these individual colors they move with their own speed, and dispersion takes place. So 7 different colors are produced. Okay, this much things are discussed by him. And whose turn is there next? Soni's turn. Yeah. Do you have your the presentation? Why? Stand up. What happened? Oh, then you must make anyhow. By tomorrow it must come. Okay, tomorrow your presentation. Now, children, read this once again. At first, read, highlight the main points, write the notes, and relevant question answers you can start with. Now you can do questions as well. By the time I'll check your copy. Okay, come on.